Hello, welcome to Enlightning. I'm Whitney, and this is my guest, Rick Osowski, who has also been my mentor. I kind of still consider you my mentor, but now maybe like it used to be mentor, friend, and then I think it's kind of gone like this, maybe a little bit. Yeah.
I'd like to think that I don't have a problem with that.
um, Welcome. This is my new setup. I'm officially going to start streaming from in here with the light board instead of out in the middle of my house. So you'll just have to remember what my house looks like. I'm not going to share that with y'all anymore. It's dig up the old episodes if you're like, what's that girl? What's her lifestyle? What would you guess it to be? Probably exactly what it is, right? Like like a ton of art everywhere and yeah, and weird colors.
Captured in the history of
Anyway,
Twitch videos.
I am loving this dog in your lap, Rick. I feel like you have like a a villain vibe about you right now. You're like,
Yeah, I mean, we had the plan for both of us to, but your cat put the kibosh on that one. So then,
yeah,
but yeah, he's very lovey and cuddly, and I mean, it's very hard to code with one hand. So
uh-huh.
sometimes my productivity is definitely reduced because of that. But for the time being,
Uh-huh.
he's very comfy and he fits right in the crook of your arm. So he's a little, depending on how long his coat is, a 7 to 9 pound Pomeranian that just loves to be there. So
What a perfect size. And what a funny thing about life in general that when you're showing love to an animal, that gives you villain vibes,
yeah,
right? It's
Bond villain.
James Bond did that to us. We have some people. Hello, good to see you again this week. Hi, Nick, the first one. You are the first one this week. And hello, Malls, good to see you. And Nick, the first one is missing the parkour running to the boardroom. So I used to run from out in my dining room area in here. It's still going to be an adventure, Nick, because there's just new things to plug in and figure out when we move from one place to the other. And I'm probably going to keep upgrading this streaming setup each week. We'll keep it exciting. We'll keep you on your toes. So my team is going to, we do a thing called Spring One Tour as part of, so throughout the year, we're going to go around the country and the world to various places to give presentations. And so I'm going to be going to Chicago soon. And Rick, that's where you are. Yeah. And it's just such a fun world that we're in where I feel like you're a close friend of mine, and I've never seen you in real life
Yep.
before. Yeah, it's
Yeah, I mean, we started working together in 2020. So that was,
uh-huh,
after everything was fully remote. I mean, we were already remote by that point for what we were doing in general. And so, I mean, the fact that it's been so long, but then also that we
uh-huh.
haven't met in person is mind blowing. So yeah, so I'm looking forward to being able to get there. And just as a plug for that, for other folks who maybe haven't attended some of those events before, I've attended past in-person ones. So I haven't done the virtual ones, but in the real life ones, they're very valuable. And then I did the Spring One Platform Conference that was in Vegas a number of years ago, and those are some of the best technical talks that I've attended. So those are the ones where when you want to know and kind of get into the details, there it's more than valuable. So if you check out the Spring One tour list and it's coming to a city near you, I would definitely recommend it.
Thanks, Rick. Our team's been working really hard on it, and we have a lot in store to make it not only informative but also super fun. So here's hoping it'll be. I have kind of a intense conference schedule coming up, and I actually haven't presented it to a live audience yet. So I'll be glad to get to get that practice in and do it with my team. And yeah, here goes nothing. So Nick says you're the first here today because it's a public holiday. You're in Ireland, right? Is that correct? What's your holiday? And Cora's here. Hi, Cora. Good to see you. You're the best. Um, and what's new with you this week, Rick?
Uh, like I said, I tried to set up my green screen so that I could play with the green
Uh-huh.
jersey and in the spirit of St. Patrick's Day. But
Oh, St.
um,
Patrick's Day. I can't believe I asked Nick what the holiday is in Ireland.
And so I was playing with that in StreamYard, but then because I have pretty much like I have a lot of cutting edge technology here, but I have essentially a light that is powered from 1950. It wasn't looking that well in the green screen, so I just tore that down. And here we are back with my normal setup. But then I did add to our little ad hoc wall over here. You can't really see it there, but it's a sticker from Ted Lasso that says, "Be curious," and I just dropped it on the floor. But it says, "Be curious, not judgmental." And so that's one of my favorite scenes and clips from the show. So for folks that are Ted Lasso fans, that's one of my favorite ones for that. And usually when I take this guy on walks, I'll listen to clips of the show when I'm doing that. And that was when we listened to yesterday. And so I got those stickers off of Etsy a couple weeks ago, and they just came in yesterday.
That's wonderful. And that's exactly my goal for this show, is to teach in a completely judgment-free zone. Because I know I've asked my fair share of silly questions, and I like to think that I'm not being judged. I honestly, probably somebody is.
There we go.
But it's not going to be me judging you, I promise. Oh, lovely. I love that. Hi, Findle. Welcome. Just on Twitter earlier, it's been a few months, but I put up, hello, Ritu. Oh, Ritu's here. She was on our team before. Hi.
Another teammate.
Another teammate. So I put a very silly question up on Twitter that I still feel a little twinge of embarrassment about, but I left it up just to be a good example. But I said, what does it mean for, I was learning about Carvel tools, and I was like, what does it mean for tools to be compostable? Thinking like it has to do with how they're getting, and I misread the word composable. They're meant to be composable. So there's small tools that can go together different ways. You can compose them differently, but I read it wrong, and I asked a silly question. And Cora is actually the one on Twitter who like gave me a very kind answer. There are no, Cora says there are no silly questions, just silly people, and silly people are the best. Thanks, Cora.
But at the same time,
even now, yeah,
the best composable tools are also compostable, because when they no longer serve their purpose, you just throw them out and then put a new one in its place. So it just goes in the pile. So it's good either way.
I love it. Thank you. See, and that's what I find when you're around good people. When you vocalize the ways you feel vulnerable, they lift you up. They don't make you feel bad about something silly you've done. They're like, that was a good try, but it actually goes like this. And yeah, so I hope to be that. I've definitely gotten that kind of wonderful atmosphere from you and Ritu and Findle and Nick, really everyone here, Cora, and I hope to be able to give it to people too who watch the show.
Yeah, that's what on my podcast, and we haven't done any new episodes lately just based off of the hectic world of everything going on. But when I was recording them regularly, like we would get in a conversation and be like, okay, this is what we're going to talk about, boom, boom, boom. And it's a mental health podcast talking about people's stories and journeys and things that they've had to overcome and things they're proud of and things that, that the trauma that they want other people to be able to work through that they already did and things like that. And so we have this set schedule of what we wanted to talk to. And then in the act of the conversation and being vulnerable, it kind of goes off in another way. And it's like, we never thought it was going to go here, but we absolutely love it. And so that's what kind of what I'm a big fan of is, when you can be vulnerable like that, that's when you're able to find out as much as possible, as opposed to kind of having your guardrails, because then if you aren't or if you have your your vulnerability guardrails up, you can only expand so much beyond that, and you're kind of limiting yourself.
And it's like in vulnerability, that's where you find connection, and that's the part that makes you human. If you're perfect all the time, it's not interesting anymore. But so speaking of imperfection, I think it's a good time for me to struggle through moving over to the light board together. But we can keep this conversation going. So behind me, there's like a TV tray right there. So I'm going to put the laptop there, and then I'm going to plug it in, and you can see on this side, that's called the confidence monitor. You can see the little lightning bolt in it. So that's where I can see myself. And then I'm going to put y'all up here so I can see the chat and like whatever's live going on here. So that's and then I'm standing not on this side of the light board, but around the side. In fact, I'll just show you. Can you see me
Yep,
back
you're
there?
good.
Hi.
Yep, you can see you there, and then you're on the bottom screen.
So I hang out. I spend a lot of time back there, just in that little space. All right, so let's walk over there together. I'm unplugging here. I think I'm gonna have to come back and turn those. I have I'll show you. So I have now a streaming desk with like the fancy lights and stuff. That's all brand new to me. And you can see inside my closet with my Dance Dance Revolution pad. My
So there is still a
youngest
little bit of
brother,
insight into there. You don't get the hallway, but you get a little bit more of the
yeah.
room.
My youngest brother is used to be nationally ranked as a DDR player, and he still likes to tour the world. He'll go to Japan a few times a year, or did before COVID, to go to DDR tournaments. So
That's, I mean, the coordination that people have to do that is amazing. So that's very impressive. But now the only thing I think of when I hear DDR is the version of DDR that they do in Paw Patrol, because that's one of my daughter's favorite shows, and they have a version of that where they dance and kind of rip off some of the songs there. And that's whenever I hear DDR, that's just that the Paw Patrol song immediately gets stuck in my head. So now I'll be thinking of that the entire time we're here.
with a dog in your lap and a Paw Patrol. Okay, I just turned the wrong knob. Let's bring that back. Yeah, here we are. Now I'm lit properly. Do I need to turn off those streaming lights? I don't think they're making a difference.
You're coming through good on my end. And
okay,
I've got
great.
you in StreamYard and in Twitch, and it's looking nice and clear on my end.
Great. I'm turning on the monitor so I can see you through my light board, and then I think we did it. Good job, everyone. I'm going to make myself big here, and then I'm also going to get rid of our names. These are our Twitter handles if you would like to follow us. I'm Wiggity Whitney. We got Rick's is small there. Let's make you big. So that's Rick.
At Osowski.
And I'm going to turn that off. Okay, here we are. Bear with me while I delete the light board while I erase it. And here's a question while I'm doing this. For those of you who are watching, who maybe already has experience with using persistent storage in Kubernetes, and what is that experience? I don't know very much about this, so I'm really looking forward to learning today. I've mentioned before that to get my feet wet with Kubernetes, one of the things I did was memorize the Kubernetes glossary. I made flashcards. So I'm kind of familiar with the terms around it, and but I'll be interested to see it all connected.
Well, I hope some people have something, because it's going to take a while to redraw everything we had from last week.
That was quite a dense board. I loved it. Okay, so from last week, we talked about a 3-layer application. And so let's give context. Last week, Rick was also the guest, and we just talked about deploying a stateless application on Kubernetes.
Yep.
So we're going to recap that and get a preliminary diagram. And then from this week, we're going to talk about adding persistent storage to that. So we had a 3-layer app. Will you remind me what the layers were?
Yeah, so you have essentially the web tier, the business logic tier, and the database tier. Okay. And so those are when we think of a traditional 3-tier web app, that's what we're generally thinking of. And most of the time when we're talking about breaking the monolith and evolving the monolith, those are the components that we're trying to figure out where the kind of new subcomponents of that are going to live in the future. So that's where we've got web tier, business logic, and then data tier. And so usually your web tier is 100% stateless. For the most part, depending on what your business logic is, it can mostly be stateless if it's talking directly to the data tier. But sometimes, depending on the application, your business logic tier is also has some stateful components to it. But last week we were basically just talking that we had a business logic tier that we were looking at for a specific use case that was going to be in itself stateless, so that we could deploy any pod anywhere across Kubernetes, and it didn't matter where it was running or what it was connecting to from kind of a front end perspective, it would be the same experience across the board.
Love it. And so then we talked about a Kubernetes, like the architecture of a Kubernetes. So Kubernetes is running across many different computers that can also be called nodes, that can also be called VMs, which is so we'll call this our control plane, and it's represented by many different nodes. And we had some overarching components on there that are going to help orchestrate our workloads. So let's so this is our control plane machines, and then we're going to have other machines, aka computers, aka VMs, that and these are going to actually have our applications running on them. Is 2, you think, good to illustrate our purposes today?
Yeah, that should be fine. I mean, we can.
Okay.
I don't think we need to do more, because then it's just kind of an exercise in more permutation. So I think we should be able to capture what we need there.
Okay. And then if any of these, the control plane components become relevant in our story today, that's when we'll add them. Does that sound good?
Yep.
Instead of trying to recap that part. And then, so we're going to call these worker nodes. And then, cool. So is this a good place to start?
This is a good place to start.
Maybe. Okay, great.
So last week when we dove in, we were talking pretty much about deploying the application and what you would do from basically a application developer. But there was kind of one underlying assumption to that, is that the Kubernetes cluster was already provided to you. And so that would be done by a Kubernetes admin of some sort. The expectation shouldn't be for you to, as a Kubernetes developer, you wouldn't necessarily always have to deploy your own cluster. You definitely can, and understanding how the cluster is deployed and what happens is definitely a plus, so that you can increase some of your mechanical sympathy to understand how the system works. But to deploy your Kubernetes application, you necessarily don't have to deploy the cluster at the same time. But today we're going to be walking that fine line a little bit more between separation of concerns and separation of roles, because there's more that you do in the storage space that a Kubernetes admin has to provide, and then a Kubernetes application developer consumes. And so sometimes you can wear the same hat and do both, but as you start to grow, as you start to scale, you're going to have individual pieces that are done differently. And sometimes if you're using managed Kubernetes services, then a lot of that Kubernetes admin type tasks are done for you automatically by the service. And then you as a developer just comes in and start hacking away and deploying, and everything's set up for you by yourself. But if you're deploying Kubernetes manually, or you're deploying it on-prem with an unmanaged service, then that's where you're going to need to understand what all of the pieces that you need to do from an admin perspective to be able to then have your users and developers take advantage and kind of consume that.
So generally with storage, the Kubernetes administrator provides the storage, and then the developer consumes the storage.
Yep, exactly.
But it's still always great to know how it works.
And there's different terms that we'll kind of jump into. And kind of last week, the 2 big phrases that I used and you were capturing were, with Kubernetes, we focus on abstraction and delegation. And so we're just going to continue that thread going here, as far as how we're abstracting traditional IT infrastructure concepts, and then how Kubernetes delegates those down the stack, so that you have more flexible control, and you have that separation of concerns, so that anybody can use that. Whereas in the past, when we had our, say, the JEE monolith, you were very rigid in, you have your computer, the whole app server goes on the computer, and then everything goes inside the app server, and there's really nothing broken down. You kind of needed to have a single admin to manage a lot of that, and there was, as far as installation capabilities, the Venn diagram was very much a closed circle, and I would use my other hand, but Ollie stole it.
You're too busy being a villain.
Yeah, and so now, like with Kubernetes, we have the ability to kind of inject another layer in there to give us the ability to have much more fine-grained control over the those modular components and those composable components to be able to help us kind of distribute those pieces. So that's what, when we're walking through this, I will probably belabor the point as far as like which role or which persona, which user is going to be doing this type of work and providing it to the other user, so that we know that that's clear. Where in the end, if you're the only one managing the system, yeah, you'll be doing all the roles. But as you go through it, understand that when you scale out, bring in more people, go to a larger organization, build a larger application, some of those will start to diversify.
Okay, wonderful. So does it make sense to talk about our stateless application and then how to add state to it?
Yep. So we'll generally, where last week we talked more about that business logic layer, this week we'll talk about, say, the data tier. There's going to be lots of ways that we could do to bring databases into Kubernetes or anything else that's there. So we're going to be talking again in the abstract, but we'll talk about how we can deploy some pods and have the managed persistent state to them without really a ton of API constructs or anything. So again, we want to talk about those atomic concepts so that you can start building up into larger use cases and understand the kind of the 80-20 of all of that. So we can catch up on how we had our pods managed by a deployment, and they were handling or they were injected with config maps and secrets, and that's kind of our stateless layer. And now we'll build a similar layer underneath of it, but it's going to have more stateful components to that, and then we'll evolve that as we go.
Okay, so what should we do next?
So, I mean, you can just draw a couple of the pods that we had for last week on your worker nodes and surround that by a deployment. And the deployment is a controller that Kubernetes provides that is capable of just deploying a uniform set of pods. So the pod is the smallest unit of scaling that we have in Kubernetes. And you can jump back to last week to hear about why it makes sense to try to stick to one container per pod for the most part. And so generally when we're thinking of pods, that's going to be when we need to scale. We just need to add more pods. And by doing that, we can use the controller in this case, which is a deployment, which is generally a stateless controller that gives you the capability to just say, give me 7 pods, give me 3 pods, give me 10 pods, and then Kubernetes figures out where those will go. But the key part there is that it's generally, in essence, designed to be a stateless controller. So you don't really have any ordering. You don't really have any concept of this is the first pod in the series, this is the second pod. You just have a set of N pods. And then those are kind of what the controller will always make sure is up and running. So that's what we're looking at when we're talking stateless.
And I think it's maybe a good to mention here that that pods are ephemeral, and if something goes wrong, then they are just gone completely, and a brand new one comes up with a new IP address.
Yep.
And so that's part of the problem that needs to be addressed with storage is how, if it's a brand new one, how does it know where the storage is or access storage?
Yep, exactly. And so that's the problem. And so you can kind of, we can probably add some control plane components here where we'll want to mention the Kubernetes API server is what everything is interacting with. So you as a developer would work with that. A Kubernetes admin would work with the Kubernetes API server to just basically control everything on the cluster. And then inside there, you've got, it's kind of a pedantic point, but you can also put etcd inside the control plane. And etcd is the backing data store for Kubernetes. And that's where the API server writes all of the state of the Kubernetes cluster into etcd. And then basically the controllers throughout the rest of the Kubernetes platform essentially make the state come to fruition or make it so for our Star Trek fans.
So etcd has both the actual state and the desired state, and then all the Kubernetes control plane components are working together to make those the same thing.
Yep. And so we talked last week about we have some configurations such as config maps and secrets that allow you to manage some stateful information and inject that into containers or to pods when they're running. But those config maps and those secrets are stored inside etcd. So that becomes a very untenable situation if you're trying to store gigabytes of information in a config map and store that in etcd and then have that move throughout the cluster. So Kubernetes prevents you from doing that so that you don't kind of topple over your cluster. So now we need to find a way to be able to store information that we're not necessarily going to be storing in a database, or sorry, storing in, yeah, it could be a database, could be somewhere else, or what a database would use underneath of it. But we need somewhere else besides etcd to store that. And that's where persistent volumes come in.
Okay.
And so if we remember that a container is simply a wrapper around a process running on a computer, and Kubernetes is managing how we're doing that, then that process can connect to storage running on that, or that is available on that same computer, or available over the network from that computer as well. So that's really what the abstraction of persistent volumes are, is how does your computer / worker node have access to a storage component that is then abstracted into Kubernetes.
So as far as the actual storage component, is that usually a storage on that is part of the same computer or node that has the application, or is that usually a whole separate set of computers?
I'll answer you in a two fashion and say yes. So the answers to both of your question, or both of your questions, is yes. And so that's really where, again, that abstraction comes into place, so that the persistent volume is the Kubernetes construct that allows you to define how you want that storage to be handled. So that gives you the ability to define a local path volume that would then be storage that is available literally on the physical hardware. But it also gives you the ability to define storage that would be backed by an AWS EBS volume, or an Azure disk, or a GCP Elastic disk. And so those are then attached via network componentry to the node, but it appears that it is essentially a locally attached node. And so those are the ability to have that abstraction and give you the ability to have super fast local storage, or externally managed redundant storage somewhere else, but then you're just connecting it into the system.
So my question then is it ever actually local, or you want to say yes to it being local because it appears local?
No, it can be local. And so in the project I'm working on right now at Seagate, we're developing a object storage offering that will that is taking advantage of that in and of itself, where we're working on a project called Cortex, and it is a object storage solution that is going to deploy on a number of on-prem instances. And so it takes advantage of mass capacity, high scale devices to provide a lot of that. And that is using direct physically attached storage directly on the node itself. So the expectation there is that you have lots of hard disks, SSDs, whatever you have attached to physical storage. And then when you create the persistent volume, there's essentially subtypes of persistent volumes that you can define in its specification to say local path or other types of local storage. And then you're saying, okay, this persistent volume routes to either this device, this volume, or however you end up having kind of managing access to that through the underlying layer. Since then, now that you're talking about physical storage, there's a number of ways that you can route to that, and using, LVMs and a lot of other storage stuff. So just know that you have physical volume, or you have persistent volumes, which is the construct in Kubernetes, that can attach to physical volumes that are on the node that the pod is running on, but it can also attach to network attached storage that is running somewhere else, but it appears like it's running on the node because of the network-based interface.
What would be a good way to represent that in the diagram? Just a line from here to here? And
so
that could be, and where, yeah.
So you can do that, or you can put a smaller volume inside the node, and then so that would represent on node storage, and then you can just draw like a dotted line to the bigger one, and then that would be a network interface. So you have the ability to do explicitly on node storage, or you have the ability to kind of essentially mirror or kind of mock network interface storage through there. So for folks that
Okay.
are kind of readily available, and I mentioned this last week, but one of the great tools to kind of discover some of this stuff, if you're
Uh-huh.
using the command line, is kube control explain. So right now, if you just
Uh-huh.
did kube control explain pod.spec.volumes, you would see all the different types of volumes that you would be able to define that are in there. And one of those would be local path, and then you see all the other different types of volumes that you can define at the pod level. And if I can type
Great.
here, I will do that one-handed while you're catching up.
Antone, hello, welcome. It says yes squared. So that question I asked a while back.
Yep.
When you when both ways are how it's usually done. Great. So we have a persistent volume that could either be its own machine accessed via a network connection, or it can be a part of a worker node machine. Would it ever be a part of a control plane machine?
Not necessarily. I mean, it could be,
Okay.
but generally you're gonna section off or cordon off your control plane, and you're not really gonna have a lot of dynamic workload running through your control plane. So most of that, when we're talking storage, it's all really gonna ever be on the worker nodes themselves.
Okay.
And so with that storage, then all of that is a byproduct of what a Kubernetes admin would be doing. You're generally not going to have a Kubernetes app dev just having, unfettered access to be able to create physical volumes and wherever they would exist, or creating additional storage inside of your cloud provider or something like that. So that's usually what a KS admin sets up. And so now how the interface to that is done with the application developer is what's called a persistent volume claim. And so that's really the seam in the role there for who is going to be setting up the storage, and then who is going to be consuming it. So what we end up doing is we can create a volume mount inside of, still a volume inside of the pod that is of type persistent volume claim. And so what you have is, sorry, Ali, I need my hand. You have persistent volumes that have a set of characteristics that the admin sets up, and then you have a persistent volume claim that the app dev writes and says, this is what I need to support storage in my application. And then when the app dev deploys your application, Kubernetes marries the two and says, this persistent volume claim is going to map to this persistent volume, and your app now has storage running under these characteristics. And so that's where we would start to evolve, where we can create another controller in your worker nodes, and then that's where we'll kind of put inside there. And I would say, if you want to blow up a pod to be a little bit bigger, then we can write inside that pod the persistent volume claim. And you have something to say? The persistent volume claim, and then eventually what we'll do to kind of talk about what the internal pieces are there as well.
Okay. So I want to repeat some of this back to you to make sure I'm understanding. Let's say the persistent volume, this might be a ridiculous number because I don't deal with this much, but let's say it's 50 gigabytes, right? And so you're saying like 1 gigabyte could be the claim that is given to a particular pod?
So it can. That'll usually depend on the type of volume it is. And so we can talk about that in a little bit. And that's usually a byproduct of another concept called a storage class. But usually what it'll do is inside of a persistent volume claim, you say, I need to be able to access it in this way, which I'll talk about again in a moment for access modes. And then it needs these characteristics. And usually one of those characteristics is a minimum size. And so if there's a 50 gigabyte persistent volume and you have a persistent volume claim for 1 gigabyte persistent volume claim, and all the other characteristics of the claim match the volume, then it'll give it to you, even though you only asked for 1 gigabyte. That can happen. And so usually what there ends up happening is you have some persistent volume provisioning that is somewhat aware of your impending workload, so you know how to kind of right size some of those volumes ahead of time, or you go into what is called dynamic provisioning, where when there's a persistent volume claim that's spun up, the Kubernetes admin has pre-configured Kubernetes to dynamically allocate persistent volumes that match those claims in a more one-to-one fashion, so that you don't have a lot of unused storage that kind of goes to waste.
Okay, that makes a lot of sense. So is this persistent volume, let's say, because of its shape, let's say it's a cake. Like, is it like a slice of cake that gets to go to the, that's going into the pod?
Yep, exactly. And so
Okay.
the pod in and of itself doesn't know that it has to go through a PVC to a PV and all of that stuff. It's basically Kubernetes is taking care of all of that, because what it ends up doing is it essentially mounts that storage directly onto the node, and then the container sees that storage as essentially native storage. So you would be able to access it just like you were to be able to access the container file system.
So, and does this go into the pod or the container?
So the PVC is defined inside the pod.
Okay.
So that's the up top is still your PV.
Mm-hmm.
And so what you're drawing there, that little piece there is the PVC. And then so label what you have inside your pod there, label that as PVC, and then draw the arrow up to your label up top there. And then I would remove because what you still have up top there is still the PV. Okay, there you go. So you're able to kind of get a small chunk of that out.
Yeah.
And the only thing, so that's fine for what we have here. So what you're able to do then is you inject that PVC, or you define the PVC in the pod, and then that takes a chunk out of persistent volumes that are available to then to do that. So if you do a kube control get PV, you'll see all the persistent volumes that are available on your system. But then if you do a kube control get PVC, you'll see all the PVCs that are namespace scoped to the current namespace you're in, because PV is a cluster construct and PVC is essentially a namespace, or like an app dev construct. So that's where you expect the application developers to create PVCs all willy-nilly, and they will only ever be able to support PVs that are either there or have prior configuration to do dynamic configuration for.
So the administrator sets up the persistent volume, and then the developer can access persistent volume claims.
The Kubernetes admin sets up persistent volumes, and the Kubernetes app dev creates PVCs to access those PVs.
Okay. Cool. Sets so this is not quite accurate. Sets up. We got persistent volume here. I feel like I want to spell out the acronym in at least one place, so that sets up PVs.
Yeah, and knowing the difference and kind of keeping that expanded acronym in your mind is good, because when you're in there in the middle of debugging something or writing something and understanding, well, what's the difference between a PV and a PVC, and since that's also the name of plastic piping, it's confusing. And so it does help to remember, I'm talking about the volume, and now I'm talking about a claim that needs to access that volume. So just instead of kind of, as we try to shorten things too often, you're not really confusing yourself when you're talking about PV versus PVC.
And there can be a lot of PVCs in one that all reference one volume, although they're different. They're referencing a different piece of the volume.
Yep.
Okay. Yeah, this is great.
And then, so from there, I mentioned matching all of those characteristics. And so that's where another concept called storage classes come in. And so when you create a PV, you will generally give it a storage class. Sometimes you don't have to. But what storage classes allows us to do is now further abstract that the storage capabilities and storage providers, so that now only are we not able, we're not just able to provide PVs to PVCs, but we can provide PVs that are of different quality, different speeds, different capabilities, different backend providers, and different overall configurations. And so what that does is you say you can create this storage class, and then you're able to say, oh, this developer only has access to these storage classes, while this developer who has a data intensive workload and we know they need to get into terabytes, they have access to these storage classes. And so now you're able to access, you're able to kind of map some of that and control some of the differences into how a PVC can then get mapped to a PV, and then how that PV can also get spun up based off of that storage class.
So we have a question in chat that's maybe related to a question that I was going to ask. I was going to ask about storage classes, like what are some examples of what storage classes might look like? But let's go back. Let's go to Abhishek's comment, which is, can you please talk a little bit more about rules for volume claims?
And so the way I would answer that, as far as I guess rules and you can throw it in chat if that's how you were intending it, but I would say as far as rules for matching volume claims to volumes. And so that's how I would expect to answer that one. So if you had a different intention, feel free to let me know and we can circle back on that one. But there's a number of types of kind of characteristics of a volume, and then Kubernetes will look to match all of those in an ordered set of kind of grouping things in a specific way to match size requests, and then storage class if it's defined, and then access mode. And so another point we haven't talked about yet is access mode, where you have multiple types there, where certain times you want volumes that are read only, and then certain types you want a volume that are read write from a single pod, and then you want volumes that are read write from many pods. And so those are the different types of access modes that we generally talk about when we're working with that. And this goes to the next question that just came in. And so thanks, Abhishek, for confirming that. Where the next piece there is what we have in the different access modes that allow us to define how pods can talk to individual volumes. And then that's also one of the key characteristics of how PVCs will map to PVs.
So when you're considering storage, access mode, which is like read-write considerations.
Yep. So the three main ones there are read-write once, which is RWO, and then read only, and then read-write many. Right. And so you have RWO, RWX, and it should be read only. I believe read only is the other one. I rarely use that one. And so that's what we should be looking at for. Let me just double check so I get that right. Where you've got you've got the ability to then write a PVC that will give you the ability to essentially map that. So you're saying, when I create this PVC, I need only one person to be able to read this, or I need only one pod to be able to read this, or I need one pod to be able to essentially own all of the data on this PVC, or I have essentially read-write. Basically, anybody can attach to it.
Is that something that the developer says they need and then it gets mapped? And so how do those rules fit in with the personas?
Yep. So what you end up having is okay. Yeah. So you have read write once, read only many, and then read write many. So ROM, I guess, is the other one that I was missing.
M and not X.
Read write once, RWO. Read only many is ROX. Yep. Okay. So ROX. And so the two main ones that I've used day in and day out are read write once and read write many. But what that does is that gives you, that will then have the volume is defined as far as that's the type of volume that you want it to function as. And so that could be something
Mm-hmm.
where that's what the admin has set it up to be, so that it
Mm-hmm.
that's what they intended to be used as, or that's what the underlying kind of storage layer can only support. Like where certain storage
Mm-hmm.
layers don't support read write many because they don't have locking mechanisms. And so something like if it's an NFS backed volume, that implicitly
Mm-hmm.
has more read write many capabilities because it has, the file system locking capabilities, versus something where you don't want to do block storage for read write many, because then you have things that are kind of competing at the same time to write to the same file system. So you have
So we have
access
a couple.
mode.
Oh, sorry.
Yep. Well, so that's why I'm just rounding out your storage considerations there. So you've got access mode,
Okay.
size, and then storage class would be the only other one that would be, if it's defined, it is another one that allows you to have that to what you're tying PVs to BVCs to.
Mm-hmm. I like that. We have some questions in chat. Can we share one PVC to different pods, or like within our 3 deployment pods, do they all have the same PVC? And also, if pods are part of a different deployment, can they have the same?
So right now, the way that we have it going is, and this is getting very far down into the weeds. So we can modify our deployment and our drawing there so that it is technically correct. But generally, in your deployment, what you do is if you specify a PVC, you're going to have that same PVC stamped out across all of your pods, so that a deployment is managing, as I said before, a uniform set of pods, so that if you have a PVC defined on the pod, every pod that gets spun up has that PVC associated with it. Which sometimes that's good, sometimes that's bad. If you need, that's where we'll talk about why we want to jump to a different controller to manage that in the long term. But for the time being, you could very easily have that same PVC mapped to all of those pods, and they would just all come back to the main storage piece on the back end. But with that said, you have to have a underlying PV that's mapping to that PVC claim that is going to support read write many and also access from multiple nodes, so that that wouldn't be something where you could have multiple pods running on different nodes all talking to the same essentially physical PV that's on your top node there. So that it would have to be a network attached storage in that instance, or network interface to the storage, to be able to have that to work in how we've drawn it today.
Okay. So it's possible we could also reference the same persistent volume on this node, but it just wouldn't be locally accessible. And is that true?
Yeah. So
it would make it definitely a network one.
So then if you end up trying to create, or you end up getting in this kind of mismatch state where if you have your PV that is defined on a node and Kubernetes is trying to run that pod on a different node, but it's assigned the PVC to that PV, it'll basically break, because it can't run a node on a different, or it can't run a pod on a different node where it's expecting locally attached storage to exist on a node that isn't there.
So to correct this, I can put another PV here, and then and this is also referencing this one, and I get rid of on a separate. It's also in the same network interface now.
So not necessarily. So that's why this is so fun, and why it wasn't so difficult, or why it wasn't such a problem. You didn't dive into this with your flashcards already. So what ends up happening is you'll end up, again, when we're doing deployments, everything has to be uniform. So there's really, without going into super cutting edge version 123 alpha level features, there's really no way to have the pods that you have in your deployment reference different PVCs. So they're always going to reference the same objects over and over again. So in that regard, you would generally connect that to, instead of a PVC, you would configure that volume to connect back to some more dynamic network storage, so that as the pod spins up, it would be able to connect to different backends as necessary. But the general part there is, as you, whatever whatever storage, and it's perfectly fine. Like if you just need to mount, like say, like website data, that's going to be the same across all the pods, then you can do that in the
Mm-hmm.
way we have it drawn here. But if you need to evolve that into saying, okay, I want to deploy, a pod, or I want to deploy a series of pods. I want to manage it from a single controller, and then I want each of those pods to have a different PVC. Now we're getting into talking about stateful sets. And so
Okay.
that's where the next level of evolution from, we have this controller that's managing a set of things, they're all uniform, but now because we want
Uh-huh.
them to all maintain different parts of our data, we've got to evolve that a little bit. And so that's where we would generally look to talk to stateful sets at for the majority of it. And again, that's the 80-20 rule. There's edge
Mm-hmm.
cases, and like I said, there's cutting edge features in 123 that are alpha level that give us some of that capability in deployments. But we're not going to kind of go into that for folks who are just trying to understand, for the most part, the broad stroke concepts for how we want to handle our data and what we should be expecting to kind of connect the dots for.
So we have a question in chat I want to get to, and then I have a question. Or actually there are 3 questions in chat. So this one is, what is the maximum size that we can allocate to a pod?
So, I mean, generally it's going to be theoretical, because if you have something that's local to the file, local to the physical storage, it would just be whatever
Mm-hmm.
the volume you can do there. Like if you're attaching local storage just for the whole device that's on there, then whatever size is there
Mm-hmm.
and whatever size, the file system and the device paths will support, you can attach that directly
Mm-hmm.
into a pod. If it's network attached storage of some sort, then it's generally whatever the backing network or storage provider is going to support. So there really isn't anything a maximum from a Kubernetes standpoint that it's
Mm-hmm.
blocking you from. It's the layers of abstraction and the layers of delegation that are going to impose those limits at some point. So
Okay.
whatever you would need, you can use that to select what type of storage you're using, and then how that would go into the pod itself.
Excellent. And this one's from a shish. Hi, I was installing a Miniopod with an existing PVC, but it failed. When I deleted the PV, it came up fine. Why can that be?
So that's where we get into the case of what's called dynamic provisioning. And
Mm-hmm.
so again, there's a lot of depth to the question here and a lot of assumptions. And so I'll kind of state my assumption as I'm answering it. But when you're installing MinIO, they leverage PVCs to talk to all of their components.
What is
Yep.
MinIO, please?
So MinIO is another open source object storage offering, similar
Okay, thank you.
to Cortex that I mentioned
Cortex.
before. And
Uh-huh.
so they deploy a feature that allows users to deploy object storage inside their own cluster. And so to do that, they deploy a stateful set, and then they manage PVCs, and then those PVCs will connect to PVs and go that way. So depending on how your cluster is configured ahead of time, if you have a storage class that has a default annotation on it, and if you end up having something where the pod was a previous deployment and then you deleted it and then you didn't clean up anything else from a PVC/PV perspective, because data is stateful and data is usually valuable, Kubernetes has made some kind of changes in the past couple of years into how they manage by default some of those stateful objects. So they generally won't by default delete PVCs and PVs when you delete a pod. And so sometimes if you're not knowledgeable about that, you can kind of get this impedance mismatch when you're redeploying things and you're trying to spin up new things, because it'll try to reuse things that are already there. But if you know that, no, I want to clean this fresh, then you have to essentially
Mm-hmm.
delete the pods, delete the PVs and PVCs, and then redeploy the pods. And then that will try to spin up a new PVC if it's using, or sorry, the PVC that's attached to the pod will try to spin up a new PVC. No, I keep saying, see, again, I keep confusing myself. The PVC will try to spin up a new PV when it's deploying it if dynamic provisioning is enabled. And so that's where
Okay.
usually you have to delete it, clear everything out, redeploy, and then it can do it there. And you have the ability to do that manually. You just have to know
Uh-huh.
kind of the inner pieces of how a PVC claim is mapped to a PV and all of that stuff. And it's if you're not needing to kind of reproduce something in place, then it's easiest just to blow everything away and restart, which is essentially what you did here, Ashish, and everything works out fine. So there are some concepts where if you're working in an environment and storage doesn't seem to be working, yet you're removing pods. When you remove your pods, do a kube control get PV and kube control get PVC and see if there's anything there that's referencing the pods that you just deleted. And if there are, that may be a case where you need to remove that information before you can deploy pods so that things can get created again.
So the very short answer is probably dynamic provisioning, which we haven't really talked about yet. Got it. And then we have another question. This is a great question. Can we extend the PVC size once we allocate it to a pod?
Yep. So there's certain underlying storage providers that will support that. So there is Kubernetes provides that by default through the interface, but then it's up to the backing storage provider that is actually managing that storage to support it on the fly. And so if you're connecting your volume to things like AWS EBS, Azure Disks, GCP Elastic Disk, things like that, those will naturally support a resize on the fly inside the pod. But if you're working with just a local volume provisioner on the local node, generally that's not supported. But there are some other ones out there that are working to support that. But then you have more kind of requirements on the underlying node infrastructure to kind of so that your storage provider has requirements and then it passes some requirements down onto the infrastructure that can do it. So the short answer is yes, you can do it. The longer kind of consultant answer is it depends, and it just depends on the underlying storage provider that is actually backing your PV there.
Excellent. And so now for our more remedial use case where we haven't talked about dynamic provisioning yet, we haven't talked about stateful sets yet, for what we have here.
Yep.
It sounds like when I've drawn this little orange PVC and all of these, that's inaccurate because the ones on this node right now don't have access to this persistent volume claim.
Well, they would if you were to, as long as we don't assume that your storage interface there, as far as your small PV and your tiny PV, as long as we're not assuming that those are interchangeable, as long as the big cake that's outside of the worker nodes is essentially something that's accessed through the network, then the way you have it drawn now is perfectly fine, because your PVC would point to the PV, and that PV would be a remote PV that would be outside of the system. And so as long as it's not expecting that PV to exist on the local node, then everything is there.
So let's just, let's not consider the local use case right now, just to keep things consistent.
Yep.
So great. So now I want to talk a little, I want to recap about storage classes to make sure I understand that before we move on, if that's okay.
Yep. So did you want to play back what you've caught so far, or do you want me to kind of dive into storage classes from the top down?
So when I think of a class, I think of it from a developer perspective as a way to stamp out a consistent something, like it would be an object or whatever in developing. But here, it's a way to stamp out a PVC with a storage class. So
the storage class is a way to stamp out a PV. So you're able to. So generally, what a storage class will do is it has in the storage class itself, and you can define storage classes for use with what is called static provisioning, or kind of everything we've talked about so far, where you have a Kubernetes admin who would be manually making all of those PVs or creating all of those PVs in Kubernetes ahead of time. But now with storage classes, you have the ability to say, you define a storage class, and inside there you define or you point it to essentially an attached provisioner, which would be some other controller that is looking for PVs to be created of this storage class, and then it knows how to create those specific volumes. So then that would be,
Is the provisioner on the control plane?
Not necessarily. It's
Okay.
there's a number of places where that provisioner would run,
Uh-huh.
and so that would be something where it could be working with there are components that run on the control plane that help with provisioning. So if you're running in a
Uh-huh.
cloud in say AWS, Azure, GCP, then inside there you have the cloud controller manager, and that's where it's going to
Uh-huh.
essentially route some of your storage requests from Kubernetes out through to talk to essentially EBS or the GCP storage layer
Okay.
and things like that. So that's where you have a controller there that would help say, oh, okay, there's this thing that is namespace or that's basically scoped to EBS and it's looking for a new volume. So go to AWS,
Mm-hmm.
spin up this volume, and then come back here, give me the details to it, and attach it to this node so that it can talk to it. So that's
Okay.
really where that provisioner would run. But then also, if you run things like there's a Rancher local provisioner and stuff like Longhorn and other CNCF projects like that, those are things that you would generally deploy on your worker nodes, and they have provisioner
Uh-huh.
logic there that would run on the worker nodes and do that work for you to kind of create and make sure that all of those PVs are created on the local nodes themselves. So generally, there's not a component in the control plane that you see that's provisioner that's doing that
Uh-huh.
work, so that it ends up being a case where if you're working with a cloud, it's generally done through the cloud controller manager. If you're working on the if you're deploying your own kind of storage layer, that's where the provisioner logic would work on the worker nodes themselves there.
Okay. So a storage class stamps out a persistent volume dynamically using a provisioner.
Yes, 100%.
Great. All right. What's next?
So as I said, now that we've got all those pieces of, we've got a PV, we've got a PVC, we've got storage classes, we know how we're able to create PVs manually, and they can talk to different types of backing storage. And we have PVCs that can consume those. And then we have storage classes that are how we define the different types of storage that we want to map out. We can go back to the problem that I mentioned
Yep.
earlier in
Yep.
our deployment, where when we're creating pods in a deployment, everything is just uniform across the board. And so everything is exactly the same, where no matter what you're creating, every pod looks exactly the same. You can delete a pod, it'll get restarted, and there's no different. But when we're deploying stateful workloads, generally we come into the understanding that we have the notion of either ordering, or that the pods need to understand or be aware of their peers, and that the backing data layers that these pods will be managing are unique and can't all talk to the same thing. So that's where a stateful set comes in, where there's some more networking components to it as well, but I won't get into that. But the Kubernetes documentation does a great job kind of walking through the different types of workloads, and they have a good explainer on what the stateful set does it for folks that want to kind of see the whole picture. But for what we're talking about here is when we're creating pods in a deployment, you generally just have random names assigned to the pods. So you have a lot of hashes and a lot of random suffixes that are added to the pods. But when you create a stateful set, you have a very predictable set of pod names. So if you create a stateful set called MyDB and it has 3 replicas, the pods that are coming out of MyDB are going to be named MyDB0, MyDB1, and MyDB2. I had to remember if I was started off doing 0 index or 1 index there. So you're able to control ordering. You're able to control the naming of those pods, so you can understand when you're running inside that pod, kind of where you are in the kind of the index of your peers. Is because if your pod name ends in -2, oh, I'm the third pod in the series here, so I have more context to know what to do. But then they also give you the ability to create volume claim templates, and so some of this was brought to deployment, and those are the kind of the super edge, cutting edge cases that I talked about earlier, but they're much more limited in scope. But this is where
What type of templates, please?
a volume claim template. So this is
Volume
where
claim template.
now
Okay.
we're able to spin up when we spin up a pod. And so this is what, in referring to Ashish's answer for the MinIO pod, since they use stateful sets, this is kind of what we're doing. When you create a new stateful set, or when you deploy a stateful set, it's going to roll out the pods that it needs to deploy. And when it rolls out those pods, each of those pods can have a uniquely defined volume attached to that. So that's how we get more long-lived and more highly controlled volumes that are attached to those pods, so that for the most part, everything is the same across these pods, except each pod now knows its own identity. Each pod knows the order it came up in for the most part. And then each pod knows that it can have unique storage, so that it will own its own storage domain, as opposed to sharing the storage domain that we had in a deployment when we used PVCs, because they were all pointing back to the same underlying PV.
Okay. That
So-
makes a lot of sense. Yeah.
So that gives you a lot of ability to be able to then manage, again, how you deploy pods, whether you need to scale up stateful sets one by one, so that the pieces can come up and essentially bootstrap the underlying data that it's managing before it adds more peers, or if something can just come up all at the same time in parallel, and then it can manage everything underneath and essentially get quorum after the fact. And so those are, you have a lot of flexibility there. Now, when you need something that's completely stateless, generally you'll go with a deployment. When you have something that requires explicit or implicit state ordering, you can use a stateful set to go that route.
Is there a use case where you'd want storage with a deployment?
Yeah, so I mean, there's a number of use cases there, and that's why. And it's ironic that we're talking about this, because this is something I'm working on right now, in solving, kind of evolving some of what we're doing, where you have deployments where you may want more than temporary storage. And so there are constructs in Kubernetes and volumes. There's a volume type called empty-dir, EMPTYDIR, and that will tell Kubernetes just spin up a local temporary volume or path on the node and attach it to this pod. When the pod goes away, the empty dir can kind of get refreshed and move on. And so that gives you local storage that you would need to write temporary files and information, so that you're not writing it to the container file system and things like that. But it's less persistent across pod restarts, whereas the ephemeral volumes that are now available, is what are kind of being brought into deployments. Those give you the ability to essentially mirror kind of the best of both worlds. You're kind of bringing empty dir and the volume claim template from stateful sets into the same thing, so that now you have the ability to create some temporary long-lived storage, but it's more it's a little bit more robust and doesn't go away as quickly, so that if you need logging information, if you need access to dumping a lot of like read write or like map reduce workloads and kind of doing some of that stuff on local disk, you can manage that, and it doesn't necessarily have to go elsewhere. So that there are reasons why you would want to do that in deployments, but generally you want to, those are going to be more edge cases, and so you end up having the ability to then have connectivity to a backing data store through API calls, as opposed to the Kubernetes layer if you need it. And then just more understanding of how all the pieces are flowing through the system, so that when you need pods that have unique storage characteristics, you have a certain set of controllers that will work well for that. And then when you have pods that just need temporary storage and it can be uniform anywhere, you have a set of controllers that work well for that. And that's generally some of the dichotomy that you have there. And it makes total sense that, and because this is what we're doing right now in the work I'm doing on a day-to-day basis, you can evolve the controllers that you're using, because very early on, you can start out using a deployment, which makes total sense. But then you're like, oh, now I need to provide unique storage to each pod for reason X. And so then you have to evaluate, does that make sense that if that storage is on Kubernetes, do I need to change that controller to now be a stateful set? Am I able to take advantage of the latest and greatest features that are in 123 to be able to use some of those local ephemeral volumes? Or and kind of just all of those trade-offs. So those are all the different patterns there to kind of discover how you're using controllers, what type of storage you need, how you need to roll out pods, and all of those different pieces. So that there is something that comes into, okay, this is a good first pass, but then now as I grow and I have the need to add more persistent storage, it's not just I need to add a volume here and move on, because you need to understand how the controller is rolling out all those pods, and you need to figure out how you want your application to consume that data, how you want it to write that data, and how you want it to own that data. And that's where some of these other concepts come into play.
So I have a couple of comments I want to call out in chat. Joy put in a lightning. Hello, Joy. Thank you for coming. And then we got a compliment. Wow, I never questioned why some pods didn't have a hash at the end. Stateful sets. Enlightened. Yes.
Yeah, that's a good one there. So thanks for sharing that, Abhishek, because that was something where for me, it took a while to understand that too, when I was just doing more debugging. And so kind of going back to your conversation with Jessica, where in there you guys mentioned that no one is implicitly smarter than anyone else. There's just different ways and different tools and different tactics. And so I don't feel I'm smarter than anyone else. I just have had 20 years of troubleshooting and 20 years of knowing how to break stuff and knowing where to look for things and knowing which rocks to turn over. So in that regard, like digging through a lot of stuff, that's where I usually jump in and just get hands on with first. And so I kind of hit the same thing. It's like, why are these pods named random suffixes and these pods have more deterministic names? And so then you kind of go up to the controller and you can see that and then understand how the stateful sets manage pods directly. And then you have with deployment managed pods, you have replica sets underneath the covers that kind of manage the different rollout versions for your pods and things. And so there's tiers of hashing and all of that stuff. And so the more you can kind of debug and kind of get into the guts, the better in my regard. And that's the way I learn better. So that's why I try to always understand the atomic unit, and then we can build on top of that to figure out the rest.
So I think what would help my understanding right now is to maybe understand how a stateful set pod looks different from a deployment pod. Do you think that would be a useful exercise?
Yep. So that's not a problem. And in and of itself, the pod itself is no different. It's just how it's managed, and then what some of the information is being injected into the pod. Because when we're creating both deployments and stateful sets, if we're going back to our kube control explain piece that I talked about before, which is really good for anyone who wants to kind of just be more efficient and speedy from the command line, you can do a kube control explain deployment.spec and see what's there. But then inside there's a template field, and the same thing goes for stateful set, where the template that is inside a deployment is what the pod template is going to be. So that is how you're defining a pod to roll out, and the deployment will create n replicas of what you have defined in that template. The same thing for stateful set. If you do kube control explain stateful set.spec.template, there's going to be a pod template in there as well that gives you the ability to see all of these pods are going to get stamped out according to how a stateful set will manage them. So in and of itself, the pods themselves are the same. You just have some metadata characteristics that are being injected differently that allow for uniqueness in a stateful set that aren't kind of considered in a deployment.
So in this stateful set pod, we would put, so it's the same type of thing where with our persistent volume, if we only have this one, there maybe is a new claim, right? I could do like a pink slice of the pie, right? And then that could be the PVC for here. Is that accurate?
Yep. So when you spin up a stateful set pod and you're using the volume claim templates, it will create a new PVC for each pod automatically.
Okay.
Because again, when you have a controller and then when you define inside that controller a template, it's going to create something new for each replica for each of the templates that you have in there. Whereas in our deployment, we're just using an explicit PVC, so it just reuses the same one over and over again.
So in a deployment, our PVC would be always the same orange piece of the pie. In a stateful set, our PVC is going to be a different slice for each pod.
Exactly.
That is very helpful. So in this one, we have a pink one and then a green one because they're all different. And then a blue one, which is a little confusing, but I only have so many colors. So we have a container, a blue container, we have a PVC here, and then we're also going to include a sticky identity, an order, right?
Yep.
And the metadata. And then is there anything else?
I mean, it's not inside the pod, but you get the ability to route directly to the pod via a service name. But we haven't really talked about the networking aspect of stateful sets, so we don't have to complicate it further for that.
Okay.
But yeah, so you've got the order and sticky identity there, and then also there's some notion of how the stateful set will handle like restarts, but that's not really any different than how you can configure a stateful set to act similar to a deployment for how it's going to roll things out when it's initially deploying things in regards to scale up and scale down. So that's not really necessarily something that needs to change or be defined here. So, and it's more of a semantic kind of comment later on.
Okay. We have, hello, EI, welcome. Says, I will watch this later. Please save it. 100%. You can come right back to the same YouTube URL that you're in now, and you'll be able to watch it from the beginning later. That was actually a really helpful exercise for me, so thank you for that. And what else do you feel like we need to cover right now that we haven't?
I mean, most of that is everything that we work with in a regular basis when we're talking about persistent storage on Kubernetes. There's another piece that we haven't really mentioned as far as types of PVs, which in the larger kind of grand scheme of things is what's called CSI, or container storage interface.
Yeah.
And so you've got that is something where, again, that's another massive kind of interface point for abstraction. And I have no help here because I don't know how far we're going to go in here, so I don't really have any direction for how you should draw what I'm talking about. So we'll see where we go, and then if you end up having any space left. But there are, like I said, there are a number of ways that existing interfaces, and when you do that kubectl explain pv.spec or pod.spec.volumes, you'll see enumerated list of volumes that you have to work with there. But that's because all of the code necessary to support those types of volumes are what are called essentially in-tree, or that's code that's contained inside the Kubernetes code base. But obviously there's a plethora of storage options that are out there that you can't all write all the same code into the Kubernetes code base, or else it would become untenable rather quickly. So similar to a couple of the other pieces, and I think we talked about some things last week, and where you have your container runtime interface, your container networking interface. The CSI is the container storage interface, which is the evolution of those components for storage, where now they have a CSI type volume, which then allows you to define additional CSI drivers on top of that then give you the ability to talk to essentially abstract storage interfaces. And so this is similar to storage classes, and this is where they'll be a little confusing, but then you create a CSI, the CSI driver runs on the system, and then it is going to create volumes of that CSI type when you essentially connect the dots between a volume of that CSI type with the storage class, and then it knows to then provision a driver or a volume of that type.
Okay. The volume defines the driver, or vice versa? The driver defines the volume.
You install the driver on the system, and then when you create the
Okay.
volume, you say it's of a CSI. It's the kind of the super type is CSI, and then inside there you can say the subtype is this specific volume type.
You install a CSI driver on your system, on your cluster, right?
Yep.
And then what's the next step?
Then you can create a PV of that's of type CSI.
Okay.
And then inside that PV specification, you define which driver you want it to use.
It seems to be going in circles for me. You use a driver to create a PV that you use to define a driver?
No, so what that'll do is you install the driver, and then you create a PV that is of type CSI. And then inside inside that PV spec, you reference the driver that was installed, and the driver will create the underlying storage that is necessary in the remote system that the CSI driver is supporting your interface to.
Okay, and then in that way, regardless of your particular cluster specifications, you have like a standardized way to make storage across clusters, like across companies, across, yeah.
Yep.
So that's the end goal is super standardized storage provisioning.
So now when you create your PVs, now you have a standard way of creating your YAMLs, creating your objects, writing that to the API server and having that stored in etcd. And then so you're able to have that kind of uniform standardized way of communicating, but then the pieces that are running and actually doing the work, they just need to extract the information essentially out of the body of that CSI PV to then know that this is relevant to me. I know what to do with these types of information. I'll create a volume here and make that accessible to Kubernetes. So it's a more abstract way of doing a lot of what we've talked about so far, so that you can have an infinite number of storage backing pieces, as opposed to only what is provided in the Kubernetes kind of tree code branch so far, or code base.
Okay. We have a question from chat. What if the admin misses to set up a PV? Ideally, pod won't come up, but there's any workaround to overcome such a scenario? So if the admin messes up how they define their persistent volume.
Yep. And so remember, when we're working here, again, Kubernetes is just that control loop. So it's going to just continually work to be able to match what etcd says the reality should be, and then what the kubelets are reporting back saying this is what reality is. So it's always going to be in that control loop, always watching, always watching, always watching. What ends up happening is it's going to report that saying, okay, I'm trying to start this pod. There's either a PVC claim, or you have a defined volume, and based off of where the scheduler and Kubernetes is trying to put this pod, it can't find that volume. So it'll tell you that when the pod is failing. So it'll generally be stuck in kind of a pre-run state. You're never going to get to like an error, so it's not going to get to crash loop back off. But the pod would never run because it needs to make sure that it has access to that beforehand. So when you do a kube control describe pod, you'll see that in the events as saying like this pod can't start because it can't find the volume. So depending on the type of volume, you would be able to then create it yourself if you have the ability to do that from an RBAC perspective or a role-based access perspective. Or you could work with your administrator to deploy what's necessary to work with those volumes and then create that later on. And then what ends up happening is, since Kubernetes is always just working on that control loop, it's just going to go ahead and keep repeating, keep trying to start the pod whenever it comes back, and always looking for those volumes to be there. So there's really nothing that you can do to start the pod that would give you to start the pod with that PVC reference or with that volume reference without the backing PVC or PV to be there. You can set some of them to be read only, or sorry, not read only. There are some ways where you can specify some optional components and being able to mount some things in an optional fashion. So not everything is 100%
Hmm.
hard coded, or it doesn't always necessarily need to be there. But for the most part, if it's saying that you're trying to start this pod and it can't find its backing volume that it's referencing, you generally need to create the volume to get it to start. Otherwise, you essentially have to modify the construct of the pod so that it will ignore the volume and then it can go about its business.
That was a great question. Thank you. I'm I'm sensing that we're slowing down, so I'm doing some extra illustration to fill
Mhm.
this space because I thought it would be nice to help visualize a storage class stamping out super consistent PVs. Oh, we got it perfect. Thank you. Good job. Perfect is we were just talking about perfection earlier. But is there anything you feel like we haven't covered, or do you feel like there's anything that's maybe could be represented here more accurately than what I've come up with as we've been talking?
I think we're good, and the questions have been great to kind of put a lot of
Yeah.
structure and context to a lot of these very abstract and mind-bending terms when you've thought of storage in certain ways for so long. So thanks for
Hmm.
all the comments, folks. But I think this is, again, if we're following the 80-20 approach and not going into every parking lot that we can figure, like every edge case has a different answer to. This is
Hmm.
generally the most robust foundation for what we want to target and how we want to target it, so that we know that we're hitting all of the main concepts. And now back to the composable piece, you can
Hmm.
end up having many different types of data workloads that run a Kubernetes now that all come back to these constructs and use them in different ways.
I I have a question as a new learner. I always see storage represented in this like little silo kind of shape, right? That I've been using
Mhm.
today, the cake, the storage cake. And is it correct to think of a piece of storage as its own computer?
So the piece of storage is generally going to be its own repository, and so that could be, you can have it be a data lake, a database, and so those are all different kind of sizes of data.
Uh-huh.
Eventually, like there has to be some compute somewhere that needs to manage how that's getting read and written.
Yes.
Um,
Uh-huh.
but generally, I mean that visual kind of goes back to the UML modeling days where like you ended up having hard disks, and those hard disks were stacked in cylinders because that's where the platters got read. So you kind of just had that cylinder view for storage, and it was kind of
Oh,
a mental mnemonic device to be able to say, oh well, that's a cylinder, and the disks are stored in cylinders, so it's kind of the same thing. So that's why
okay.
you're drawing that cylinder without even realizing
Like
it.
a spindle
Um,
of CDs? Okay.
yep, exactly. Um,
Uh-huh.
and so well, I mean, actually, that's what I've got. Like one of the it's basically inside of this disk here. You just have lots
Uh-huh.
of, so this is a fancy hard disk. And so inside, this is an old hard disk where it's only got,
Oh yeah.
wow, this is 160 gigabytes of storage. So this is blazing. But like, inside here, you've got many layers of the disk, and then that
Uh-huh.
has spindles that read it back and forth and everything, or not many layers. This could just be one or two, but other types of disks have different ones.
Uh-huh.
And then so if you were to take this casing off, the data is stored on a stack of cylinders. So that's kind of the same
Uh-huh.
way that you're looking at for those things there.
That's wonderful. I love knowing that history or understanding that a little more. And then maybe I like that visual too of that because it's not its own computer, but I guess I'm trying to like just in my mental model, like sometimes thinking about what's happening on a physical level is helpful for
Mhm.
me. And so I was just trying to get a sense of like is there a reason why a lot of volumes would live on one computer, or is a volume a computer, or it's almost, it depends, right? It probably has
Yep.
reasons to go every way.
Yep.
Yeah.
It depends. So if you have
So,
if you have large racks of systems that have tons of attached storage, which is the use case that Cortex is trying to solve for,
Mm-hmm.
then that's what like we're looking to provide some minimal compute on those systems, which is the Kubernetes kind of layer that we're deploying. And then it just has tons and tons of attached storage that will be locally attached to that system versus
Mm-hmm.
other components where you have a remote storage interface that somebody else is providing the storage way off somewhere else in somebody else's data center. And I know I have got terabytes of storage to be able to do that. And I just write information to it. So when I know I need to get
Mm-hmm.
it, it's there. So like you can think of that as far as like the difference between like a disk that's attached to your physical computer that you're holding in your hand versus
Mm-hmm.
something like Google Drive where somebody else has that storage where it's a storage interface, but there's obviously
Mm-hmm.
some compute and some logic and some web logic and all of that stuff kind of deployed
Yeah,
on there so that you can access the storage. So you have all
that makes
sorts
sense.
of everything in between as far as what is a
Yeah.
computer, what is storage, and everything else as far as how you're
Uh-huh.
surfacing that storage capability.
Mullet has a question. Do you put databases in your storage, or like
Yep.
what
So
types of
so
things are going to go in storage?
So
Yeah.
that's what I was saying when you have all of these now atomic components, that's how you can
Uh-huh.
then construct all of this stuff. So you have lots of different data applications. So you have databases, you have, data streaming services. So if you were deploying something like MySQL, that'll get deployed as a stateful set using PVs on Kubernetes. When you deploy Kafka,
Okay.
that will use a stateful set and that will use underlying PVs to store its data. So you have all different types of data workloads where we kind of evolved past like
Okay.
the only thing that's stateful is a database. You have plenty of types of stateful applications. And all of those kind of data workloads will use these components in some way to do that. And that's really where the evolution of data on Kubernetes has come in the past couple of years. Whereas you had kind of a rocket ride for getting stateless applications into Kubernetes in like the first 5 years. And then everybody was
Uh-huh.
like, no, don't put any data in Kubernetes. Like you want to keep your databases outside. And only in the past
Uh-huh.
couple of years has that been really the kind of the long tail for data on Kubernetes has caught up to where the fervor was initially as well.
Okay. And then what are some types of data workloads? So besides databases or Kafka, there could be a data lake. If that would maybe count
Yep. So a
as
data lake, you've got big data workloads, which are generally like Hadoop / MapReduce type workloads.
okay. Yeah.
You've got all of your machine learning. You've got
Okay.
a lot of kind of that then goes into a very large, broad spectrum of different types of workloads
Uh-huh.
that you have for the types of data that's out there. So data pipelining, data streaming,
Mm-hmm.
data archiving, data warehousing, whether your data's hot, your data's cold, and then whether you want to do that, whether all of that's in real time or batch. So you have kind of a couple of dimensions across all of these different types of data workloads, and then you kind of pick one element out of each of those workloads, or sorry, each of those
Mm-hmm.
dimensions, and that kind of gives you a very specific data workload that there are products out there that solve that use case.
Cool. And we have a question. Can we assign thin and thick provisioning for PVC?
Yep. So, I mean, thin and thick provisioning is usually, something where it's when you're.
We
Go ahead.
define what that is.
Yep.
What
So that's what
okay.
I was going to mention.
Oh,
So,
sorry. My
that's
bad.
usually when you're referencing more on virtualized infrastructure, but it does map out elsewhere. Where thin provisioning is when you say I want a volume of 20 gigabytes. It'll give you something that's say 2 gigabytes, and then as you start to use that, it will start growing the provisioning to the upper bound that you had set originally. Whereas thick provisioning, it ends up saying, give me 20 gigabytes, and so you cut off a 20 gigabyte chunk and you give it to them right away. So that gives you the ability to be able to manage your storage as people need it. Because I mean, like in the room that I'm sitting in right now, I've probably got a couple of terabytes worth of storage, but I'm probably only using a fraction of that is actually being there. So like, you don't need to give everybody 100% of what they ask for right away if they're not going to use it. So that's kind of where thin and thick provisioning go. And a lot of that is at the virtualization layer when you're using, vSphere and VMware and a lot of those products to be able to get efficient storage. A lot of that is done under the covers with when we're talking about all of these other pieces that we talked about before, when you have the specific volumes and configurations, the CSI drivers that manage things in a certain way, how you want the provisioner to handle that when it's spinning up dynamic volumes. So the short answer is yes, you can assign thin and thick provisioning, but it depends on the underlying storage that you're assigning it to and how that will work that way.
Yeah, that's helpful. I was thinking about the CSI use case. And is it correct to say that CSI would be good to, like, if you're managing like multi-vendor, multi-cloud workloads, having a super standardized, that would be the reason you would want to get into the CSI stuff?
Yeah, so or you have very specialized storage requirements where you have the ability to be able to create very specific CSI drivers that will map to exactly how your backing data store is set up. And so instead of having instead of like exposing access to that data store through a very outdated way, using traditional like NFS type paths or something like that, you're able to provide more optimized communication back and forth with that. So you have, if you end up having a ton of different storage capabilities across the board, that gives you access to that to be able to use those CSI drivers to be able to calm down. You can go hop down. So you can do that through CSI drivers, and then you can end up having a number of ways where if you have completely discrete workloads, but you want to have the same type of administration and capability on top, that's where CSI drivers come in, because again, you can have those very specific CSI configurations that allow you to do that, and then the app dev really doesn't know the difference, but the administrator can say, oh yeah, these types of workloads we want to go over here, and we've got this whole server farm over here set up to do our production, and then we've got this stuff over here that's a very completely different type of experimental storage that is very temporal or kind of ephemeral. So with CSI drivers, you have that highly optimized storage capability set.
That's very helpful. Thank you. And this goes with our storage considerations and size. I drew my cake slices very even, but it would be true that some cake slices can be really big, right?
Yep, absolutely.
Okay. And then we have a question in the chat. If it's a network-based PV and there's a network issue, does Kubernetes consistently check on network connection, or is it purely up to the application to handle?
It's usually up to the application to handle. Kubernetes will check when it's trying to start up that pod, to kind of go back to your previous question. So Kubernetes will try to make sure everything is happy and that it can essentially mount the volume to the node that the pod is going to be running on before the pod is started. And so if it fails there, it won't ever start. But then once the kind of pod goes on, once the pod is running because all of its requirements are met, if there's a network interruption after that, it's generally up to the application to kind of say that this is no longer writable, this is no longer doable, and figure out what it wants to do at that point.
This has been wonderful. I'm getting some wrap-up vibes. Is there anything you feel like we need to touch on before we say goodbye today? Or does anyone have any more questions?
From my point of view, this has been good. I think between last week and this week, we've got all of those atomic units for what does it mean to be able to build stuff on Kubernetes and run this from an app dev perspective. There's, as I said in kind of opening last week, there's miles and miles and miles of parking lots here that we could go down for all of these questions and where different things and how we're creating things and how we manage things. Some of which you'll get into in the upcoming weeks with Carlos and some of the other guests for topics you've got there. But I think these give everybody the foundation to now understand where, when you're deploying things that are magic on top, eventually it has to boil down to these components. So you know why these components are being used in that way when you're doing some of that magic. Yeah.
It's not, we're the magicians now. It's not magic to us anymore. We understand how the trick works.
Yep. Behind the curtain, or behind the light board, I should say.
So that makes me remember to say thank you for the reminder that Carlos will be on next week, next Thursday, and we're going to be talking about what is Knative serving. So if you don't know already, Knative is a technology that is built on top of Kubernetes, and it enhances and simplifies the way that your applications run on Kubernetes. So all of the components we talked about last week, especially, we'll be able to see how those are working underneath, but then we're going to add some components on top of that to improve Kubernetes. So that's going to be super fun. I'm excited.
Yep. Looking forward to that one.
Yeah. And then, yeah, when you see Rick later in the chat, be sure to say hi to him. And I look forward, Rick, to meeting you in Chicago soon.
Yep. I've already got it on the calendar, and I'll be signing up for the Spring One tour this afternoon.
Wonderful. Thank you, everybody, for coming. Thanks to everyone who watches the replay. I appreciate you very much, and I'll see you next week. Bye, y'all.
See ya.